This is the first of 3 videos just to, in 4.7 part 1, to really solidify the idea of what happens or how do we get the sine and cosine and tangent inverse graphs. Now for this one I'm going to be looking at sine inverse because what you see right here is y equals sine of x. Now just a couple of things I want to point out about this graph. It's not really typical as far as how we label the graph, but I just want to make mention of the fact that this is sine. We know that sine has an amplitude of 1, and so it goes up to positive 1 and it goes down to negative 1. Also, the period on sine, we know that the period, when it is not modified, is 2 pi. Well, look at where this goes. This graph, I've made it so that we have tick marks here that are square so that this grid is not distorted in any way. So these are actual numbers. This is 1, 2, 3, 4, 5, 6. But notice that the period being 2 pi, the period ends right about there. Now 2 pi is approximately 6.28. So that makes sense here because that represents, in fact, 2 pi. The middle one, which is just slightly over 3, that's 3.14. That represents pi. And you can kind of go from there. You can make the marks in between as well and see that this is pi over 2 and so on. And so I just want you to be aware that those marks, those labels will still be relevant for this, but I'm putting it into just tick marks so that this graph isn't distorted in any way, so it's got a square grid. It's not stretched or shrunk vertically or horizontally. So we're going to be looking at this graph here, and we're going to talk about the inverse of it. So the inverse is done, as you know, as I mentioned in the last video, the inverse is done here when we flip the graph over the line y equals x, so over this dotted line. Now I need to be able to erase some stuff, and so what I'm going to do here is I've got this, I'm going to have this sheet of let's see how it goes, there we go. I've got this overlay for my graph right here. And I'm going to do this to show you guys how it is this thing actually gets flipped over and so that it actually looks like an inverse in this case. And then we're going to use that to figure out the domain and range of an inverse sine graph. So here's what I'm going to do with that. I'm going to flip it over that line, y equals x. And I hope you can see here, I hope you can agree with me that that does actually look like a reflection over the line y equals x, or a mirror image over that line. Hopefully you can see that that seems quite reasonable in this case. Now what I'm going to do with this is I'm going to just remember the fact that with sine inverse, cosine inverse, tangent inverse, they do have to be functions. And if they're not functions, then we can't really work with them. And so they are called inverse functions for a reason. But as you'll note here, this line, this red inverse as it looks, doesn't pass the vertical line test. And so we're going to have to modify this a little bit to make sure that that happens. And then we're going to label some points based on what we know. So I'm just basically going to start from the middle, and I think about, all right, I'm going to go up until I start turning around. Because once I start turning around, that's when this thing violates the vertical line test. And so if I started from 0 and going up, I actually have to get rid of a decent amount of this graph. And so I'm just going to erase this graph to about right there, because that's when it was turning around. Then I got to go on the bottom side as well. We start at 0 again, just going backwards to see if it repeats anywhere. And what we're finding is that it's fine until eventually right here it starts turning around. And so I have to get rid of this stuff because after this point it starts violating the vertical line test. And so what we're left with is just this tiny little remnant of what the original graph should have been. But now the good thing is that we have a function. So we're going to try to work with this function, but these are the only points, the points that you see here, this little segment is the only stuff that actually works from this one. So we're going to define what that is. Now if you'll remember, inverses, the algebraic trick is that we can just flip x and y and determine what those endpoints are going to be. So what I'm doing right here is I'm just noting where this flipped over. This point here flipped over to the line to get this point. If I look on my original graph right here, this point flipped over the line to get that point. And so I'm going to use those to label. Now, from that last piece of paper that I had up here, I told you that it goes to pi and 2 pi based on the period that we've played out here. So what that means is that this dot is actually halfway between 0 and pi, so that's going to be pi over 2. Well, the highest point is 1, so this is the point pi over 2, 1. In a similar way, I can label this other black dot on the other side. This one is negative pi over 2 and negative 1. And so I'm doing this in order to be able to label the stuff on the red line. So the red line is really what I'm concerned about, what's important to me. And so now I have to keep in mind the fact that the red curve is actually the inverse of the black curve. And so all I have to do to get these points is just flip x and y. So that red point there is going to be negative 1 and then negative pi over 2. And then up here, we're talking about 1. Oops, excuse me with that. We flip these two around, and then we have 1 comma pi over 2. So that's what we're looking at in terms of the placement here on those values. So given those 2 points, here's what it's going to mean to us. That's going to help us figure out where the domain and range are on this graph and what values we will be able to use eventually. And that's a really important piece to this one. I'm going to put up another version of this same thing. I've labeled these ones already, and here's what I want you to get out of this. We go from, if we're talking domain, that is x values, we go from negative 1 to positive 1 if we're just talking about the inverse. So that means our domain is between negative 1 and 1. For our range, that's the y values, that goes between negative pi over 2 and pi over 2 based on the way we set up those dots and the way we flip them. So we've got a domain and range here, and what this is going to help us do is it's going to help us to decide when is it okay to even use sine inverse to solve a problem. And note the fact that we've got square brackets around each one because it's a hard stop on each of those points. So that overall is just the way that we come up with this line right here. You're going to see a summary of this line later on in the lesson, but I just want you to know where that's coming from first. We'll summarize it, put all the information that you need on one page, but for now, that's kind of what we're looking at here. So hopefully that gives you a little bit better idea of where the graph of sine inverse comes from.